This video is the 2023 higher level question C2, which is a structural forms question. So just having a look at the question, the image on the right shows a glamping tent. The projections of a similar glamping tent are shown in figure C2 below. The curved surface is produced by translating the generating parabola ABC in a vertical position along the parabolic curve EBD, which is shown in elevation. B is the vertex of both the parabola ABC and the parabola EBD as shown. We're asked to draw the given elevation of the parabolic curve EBD. For part B, we're asked to draw the end view of the generating parabola ABC. C is project the plan and complete the elevation of the tent, and then finally part D is determine the true shape of the curve EC. So we're going to start with the elevation, so as to draw the parabolic curve EBD. Now, just noticing if you look at the questions there on the right hand side of it from kind of the curve BD down, you've got 1, 2, 3, 4, 5 segments. So if they're suggesting 5 segments in the question, you probably should be dividing using your construction with 5 segments as well. So let's start by just drawing our XY line. Now, also I should mention in the question the scale is 1:200, so 22 there is 22,000 millimeters. Divide that by 200, we're at 110. So I'm just going to pick a point here, and I'm going to call that CA in the elevation. 110 this way is point D, and I'm going to draw the rectangle that's going to contain this. Parabola. The height up to point B here is up 16 meters, which converted with my scale is 80. Now we're also told that point E here is out 11. So 11 meters, going to divide that by 200, should be 55. So I'm just going to locate that 55 out here as well next. So just measuring out 55 and projecting that line up there. So this is the area that we're going to be mostly working in. I've got 110 here, I've got 80 here, and we're kind of told 5 divisions. So I'm going to divide that up into 5 equal sections. So 111 divided by 5 is going to give me 22. So I can mark off sections of 22 here. And then for this side, we're at 80. Dividing that by 5 is going to give us heights of 16. And 32. So just going to label all of the points, starting at D here, that's 0, 1, 2, 3, 4, and again starting at D, 1, 2, 3, and 4. Points on this side here are going to join up to the vertex B. Where they cross the corresponding line, so like 4 here for example, crosses the other 4 line at this point. There are points on our curve. This is the 3's cross, 2's crossing, and the 1 crossing. So now we can draw the best curve that we can. It's going to pass through each of these points, starting down there at D. And that gives us the right hand side of that parabolic curve. We still need the left hand side. A couple of different ways you can do this. You can measure just using axial symmetry, which is what I'm going to do, or just redo all the construction on the left hand side. So I'm going to take each point at this point here, project that across the other side, and this one here. That might not be enough. From the central axis here where BCA is, copy that onto the other side. Same thing this distance here. and this one. So I need to get down here to D. I don't know where D is, so I do need to take this point here and project this one across. And that's over here on this side. You could also, I suppose, find where 55 mil is in here and then mirror that onto the other side as well. I'm just going to draw this in this way. So this here is going to be E where it crosses. So that there is E. And that finishes out part A, which is draw the given elevation of the parabolic curve EBD. The bit that's down here comes later. That's part C of the question. So the next part now is part B, which is draw the end view of the generating parabola ABC. So again, somewhere off out over here. The 20 that we're given, divide that by 200 and we get 100 across the front here. So this is 100, 50 is going to be our middle piece. Put in your axis line. Again, we're going with 5 divisions. Well, we have 5 divisions here. We may as well save ourselves with the height. So these are all the same. These 16s. And then down here at the bottom, so the full width was 100. This bit of it is only 50. So just divisions of 10 on this side, and I'm still going to have my 5 equal divisions. So again, label starting with 0 down here, 1, 2, 3, and 4, and 1, 2, 3, and 4. These ones here are going to go parallel to the axis, which will be vertical lines. And just like last time, these ones here are going to join up to the top to point B, with A here and C here. So all light construction lines starting out. Okay, so where the 1s cross each other is a point, where the 2s, so 2 and 2, 3 and 3 cross each other here, and 4 here. 0 up to 1. Curve that passes through each of them. And again, you need to mirror these points onto the other side of this axis just to get the points. So here, or redo the whole construction. Both will give you the same result. So that is part B of the question, which is draw the generating parabola ABC. So part C of the question is to project the plan and complete the elevation of the tent. So we're going to put our plan down underneath here, projecting the main points down. We're given no measurements for the positioning or anything like this, but what we do know and should know from this topic is that the width at ABC, this is the full width, which is here, so this width will apply to here somewhere. So I need 100 there, and just a little bit of space above it. So 50 either side here gives me the required distance. With C down here, this is B up on top, and this is A. And then I also have over here as D. This curve down here is not an ellipse, it is not a parabola. It is a generated curve based on points and projection. Okay, so you cannot draw an ellipse here, you cannot draw a parabola here, they are not the same. So I'm going to project each of these divisions that I have up here down. They're going to just be handy for the points that I need. So take each of these down this way. Now, the height here corresponds to a particular width on the end view. So I'm going to measure this height here, transfer that height from the top. So I'm measuring from the top. So remember in the question it says that it translates along this curve. So B is always at the top. So I'm going to measure, let's say, this distance here, transfer that from the top, and that's going to give me the corresponding width, which I can then apply down here. So measuring with my compass from the top down to my XY line is this height here. So measuring from B down to here. That is going to give me a set width for this part of the curve. I'm going to just do an orange so we can see it. And I can then take this width here, and I was underneath this one, so I can mark that either side here. So that's this distance and this distance here. So that's my orange distance. Going to do the same thing now for the height from point 3 here that I have. So measuring the height from the elevation, again measuring down from B, always measuring from the top. That's going to give me a new line here. So I can again measure with my compass. I'm going to measure from the center out to the side and mark that onto the correct line down here in plan. So all of these are points then on that curve that I'm looking for. Can do it again, measuring the height. So from here down, it's not projected across, it's measuring height, transferring that height into the end view, and then measuring and transferring that width. You could project that width down into the plan if you wish, but I think it's just better to keep it separate and just transfer it as distances. At least then you know you're always transferring heights or distances, and you're not going to get confused around which one am I supposed to be projecting. So I'm measuring this final height here. Check a new color. This gives me this width. I'm going to measure that width again and mark that onto the final one. Okay, so now I have a number of different points on my curve here, and I can join them together as best I can. And that gives us the right hand side of the plan. We still need to locate the left hand side of it, but that is just projecting E from here down into the plan view. I can extend on this line BD that I have, and then just drawing straight lines between A and, sorry, that's the wrong point. I was fixing that, so it's this point here I need to be projecting point E. Projecting that one down where this crosses here, that's the line that I'm looking for. So that's E, and here also C to E. And that completes the plan. Still need to do the bit of the curve that we have here from the elevation, and that's going to be based on something similar to what we did here, just working it backwards. So I'm going to take a couple of points here. I need to find just a couple of divisions. To complete the elevation here, it's this curve. I didn't hit record. We're measuring a distance down here, so I'm going to measure this distance down here in plan and transfer that. So I'm measuring from the center out to this point here, which giving me this point, this distance out here. project that height up until it hits the curve, and this distance has a corresponding height, which is h1 here. So I'm measuring this height h1 here, and I'm going to apply that down from here. So I'm measuring this height, marking that down. Do the same thing here, going to measure this distance, so the distance from the center line out to the line AE. Taking this distance on my compass, I'm going to mark it over here, project this up again just like we did with the previous one until it hits the curve, and I'm going to measure the vertical height from B down to this point on the curve. Then applying that height over here again, that's going to give me another point, so it's on that same line projected from the plan, another point on the curve, and I draw in the best curve that I can that passes through each of those points. So I'm measuring the distance down here in plan, measuring this distance down here in plan, transferring that over here and projecting up till it hits the curve, which is going to give me a corresponding height, taking this height and marking it down from the curve down. It's not from B, it's from the curve down, which is going to give me the point on the curve that I'm looking for. So the final part of this part, D, is just to find the true shape of the curve EC. So there's two ways. You can rotate this view around here, project up all your points, so 1, 2, 3, 4, and project your heights across. I'm going to take an x1, y1 line here, so this is this one. Project each of the points out. And I'm going to measure the heights from the elevation. So C here is on the ground, so that point is fine where that is. For this one, measuring from the XY line up to the point, this time rather than measuring down, so this gives me my point here. Again, from the XY line, measuring my height up here, and then measuring up the height of E. This one here. So again, draw the best curve that you can that passes through each of these points, and then just label it as your true shape. And then that completes our question.